Hi, in this video we'll be doing the analysis regarding the basic data visualization procedure which is usually done in our studio, and for that we'll be using or utilizing a very famous library that is known as ggplot2, where GG stands for Grammar of Graphics, implemented by Hardley and Wickham, and it produces some beautiful or elegant graphics. And apart from this, we'll be using two extensions of this library, GGally and ggpubr. Since the concept behind this ggplot2 is that it divides the plot into three different fundamental parts. The first one is the data, actually the name of the data which you'll be using while performing the data visualization analysis, and the aesthetics, which are nothing. These are the coordinates of your plot. Say for example, on what you want to portray or reflect on x-axis or horizontal axis, and what you want to show on the y-axis or vertical axis. Then the geometry, and how to execute the filling of colors, and how you want to categorize the things within that particular plot. And in order to perform this, we'll be using soil data, where we have got three variables, nitrogen, phosphorus and potassium, and we have three different soils from three different locations like Shalimar, and then we have another location that is Benehama, and then we have another location that is Vadura. So we have three soils, I mean to say we have soils from three different locations, and we have three variables, and we want to plot some beautiful plots which will give us information about the structure of the data set, the correlation or the association, the density and the scatteredness also. And for that we will be using a function that is known as ggpairs. Okay, then ggpairs followed by the name of the data. Say soil is the name of my data, then comma, the second part is to add the aesthetics to it. Then within that aesthetics, we want to put some colors to the different categories. In our example, we have three different categories or three different locations. So we will write color is equal to soils. Since if you will see the structure of the data set, the soils is actually the variable which is discrete in nature, or it is a character or a factor variable. It has got three groups. One is Shalimar, again I will show you. Then we have another group that is Benehama, and we have Vadro. Since the data is already imported to my R console, then I'll click on this run option. Then within fraction of seconds we will get a very elegant graph. Okay, here we are. You can see we have three different categories, and every category is being represented by a particular color. Like Benehama is by red color, Shalimar is by green color, and Vadura is by a bit bluish color. And you will find a lot of information is available in this plot. You have box plots on one side, you have some density plots on another side, you have some bar plots also, you have some scatter plots also. And the good thing about this that you can see the correlation between variables and among the groups also, or within the locations, or within the soil types also in this example. For example, the correlation here between potassium, overall correlation between potassium and nitrogen is 0.7, which is quite significant. But within a particular location like Benehama, it is 0.3, and in Shalimar you have 0.139, and in Vadura it is 0.10. Likewise, you can assess the correlation among other groups also. And another thing is that you have an idea about this box plot also. which is nothing which gives us, actually these box plots are used for outline detections also, but they give us an idea about the overall basic summarization or the structure of the data. Since you can see these are the minimum and maximum values, and these boxes are being categorized into 3 quartiles, first, second and third quartile, and in between the second quartile is nothing, it is the median. Then we have every color represents a different category or a different soil type, and you can see some of the types are more peaked, and you have some kind of a bimodal distribution in some, so you can find out the density plots and the scatter plots also, and the different colors represent a different group. So this is a very quite informative graph, and instead of plotting box plot then performing the correlation analysis, then seeing the scatterness and all this, you will get all 3 informations in one plot. Then we can do also an analysis of variance, like for that we used to apply the library that is known as DOE bioresearch, or we can take the help of gggali or some other libraries like agroar. But as far as the data visualization is concerned, so we can simply write, say we'll write the name of some function, say for example fit, then followed by ggboxplot. Say for example we want to a box plot, and after that I have to write the name of the data set, then define my x-axis. I want to put my this categorical variable on my x-axis. Since I have 3 variables in my data, the categorical variable or the defining variable is soils, and we have 3 different categories, and I want to evaluate all these soils with respect to these variables. Say for example with first nitrogen, then in y-axis I will put nitrogen here. Then after that what I have to do, I have to fill what? I have to fill the color of what? The 3 different soil types. Then add is equal to, within inverted commas, jitter. I want to give some noise or add some dots to the vector which I am creating. Then put this plus sign, then I will write stat underscore compare, means since I'm interested to evaluate all these 3 different categories of soils, then I will write label.x, since it gives us a numeric coordinates to be used for absolute positioning of the label. Okay, I will click on this. Then after that 1.5 by default. The method I want to use is analysis of variance. Then I will click on this and let us see what will happen now. I'll write fit. Okay, we'll be having a plot like this, and if you will stretch this, now you can see the function which we have used here. We first use the name of the data set, then on x-axis the category or the categorical variable, it is here. We have 3 different categories. Then on y-axis I placed the name of nitrogen, then fill I applied different colors for 3 different categories, and you can see this plot gives us an idea about whether all these 3 different categories or these 3 different soils are significantly different from each other with respect to this particular variable. since we have a p-value which is quite significant. So from this simple plot we can conclude that these three different categories or the objects of comparison, they are significantly different from each other with respect to a particular variable. Similarly, you can instead of nitrogen you can use the another variable also here, like we have other variables like this, phosphorus, potassium, and if you have so many variables you can do or perform the analysis like that. So in order to do the basic data visualization in RStudio, for that this ggplot library is highly recommended, and you can use the extensions of these two, and in order to put various plots together so that it will save your space on a particular format or where you want to portray your graphs. For that we usually use ggpubr. Hope this video will be quite beneficial for all the persons or the users or the viewers who will see this video. Thank you.